So the title is Elastic Load Balancing and Auto-Scaling, but we'll be mostly concerned with auto-scaling. The presentation, as well as the code that I'll show later, is in this GitHub repository. So it's very easy to remember. So ZHGeeks, which is the name of the group, /presentations. So feel free to go there and grab the presentation, go the code and play around with it. Okay, so the motivation for all of this, like why are people bothering with auto-scaling? It's hard. Nobody likes you. It's expensive. Okay. So why are we doing with this? Well, auto-scaling is sort of the holy grail. Right. I'm sorry to interrupt you, but this is a chance to get the network set up. If I could type. Here. Okay, I'll try it. Okay, this purple line is a bit of a holy grail in IT. So, can you see this diagram? Can you see? Okay. So what people have done so far is the green stairs. Okay. So you basically have a service or some kind of service, and you are trying to figure out how much demand is there for the service. And then you do something called provisioning capacity. Sounds serious, huh? The provision capacity. Wow. Okay. And that process of provisioning capacity usually took months. Really mean months. Ordering servers, ordering space in your colocation data center or whatever. Okay. Going there, and getting all the services into the racks, and getting things set up. So we're talking about months. Okay. And people talk in this context about capital expenditure. Why? Because you have to put cash on the table up front. Okay, so this is not something you can do in a pay-as-you-go fashion. If you want a server, you have to pay for it. Okay, and because it takes months to provision capacity in a traditional data center, you don't just buy one or two. You usually buy like 10 or 20 because it's a lot of hassle. But it's a great deal to go and provision this capacity. So what you end up with is all capacity. So basically, see these stairs? You basically need to put in more kit than you actually think you will need, so that your sysadmins can enjoy life for the next 6 months, and then it's time to provision some more capacity again. Okay, and so basically you're always sort of either having too much capacity. You basically your money is tied to servers which are not actually used. Okay? Or you have too little capacity, okay? Because ideally, if your business is doing well, the number of users will increase, so there will be more load, more demand for your service. At some point in time, your existing server capacity will not be able to sustain the load. Okay. In which case, so you are basically under capacity. So this is the point at which the yellow line of load breaks through the green line. Okay. And at that point, your users are typically going to be very unhappy, and you will probably be people losing users. Okay? So that's the classical traditional IT provisioning problem. Okay. And what people wanted for a long time is something like this purple line. Okay? Which is basically, it's like a shadow. It's trailing your load curve. Okay? So you have load, your people who are wanting to use your service, and in some auto-magic way, your capacity of basically is growing and shrinking with that load line. Okay? So this is what we're talking about. This is what auto-scaling is all about. Auto-scaling means as the load grows, so does your capacity, and as the load drops down, let's say over a weekend or whatever, then you deprovision. You basically get rid of servers, and you don't incur the cost. You don't need to have like a fixed static server capacity which you have to pay for all the time. Okay, so this is today's agenda. This is what we'll be talking about. So, how does Amazon make this possible? Okay. Well, by offering a number of services. So typically, you would use something called an elastic load balancer, and behind that load balancer, you would have a number of virtual machines, of instances. Okay. But the idea here being is that the elastic load balancer is exposed through public domain or through an IP, and this is where all the traffic arrives. It's load balancing across all your instances, and you have something called an auto-scaling group associated with the setup. Okay? And you also have another service called CloudWatch. So what Amazon is doing is you can, when you bring up an instance, you can tell Amazon, I want metrics for this machine. So I want you to watch this machine and tell me how it's doing in terms of CPU, in terms of traffic, network traffic, and or disk reads and writes. Okay. And then based on these metrics, you can even notion how well or how loaded your machines behind the elastic load balancer are, and you can then add instances or different instances. So if you really have some kind of very cool service or some very critical service that must not go down for whatever reason, okay, what you will typically do is you will have this auto-scaling group or this load balancer be associated with instances in a number of so-called availability zones. Okay. So the way Amazon Web Services operate is, so they offer these services in a number of regions. So there's a region in US West, there's one US East, and there's a region from Western Europe, so where all the data centers are in Western Ireland. And I believe there's also now an Asia Pacific region based in Singapore. So you basically have to say, sure, I want to make use of this service, I will consume them, and then you have to specify in which region. Okay. And a region falls apart into something called availability zones. And the best way to think about an availability zone is as of a separate, like a data center, with separate cooling, separate power, like a geographically distinct data center. So if a meteorite hits one availability zones, the other ones should still be standing up and basically pumping traffic. Okay? So hence the advice here, if your service is critical and you want high availability, then you want to deploy instances running in a number of availability zones. Okay? There's one caveat then. Hey. So all these availability zones are interconnected with fairly well-performing like tubes, pipes, of traffic. But you have to pay for traffic that goes across availability zones. Okay. So this is particularly applicable to things like database. If you set up database application, okay, and your replicas, your slaves, you have a master in one zone and a bunch of replicas in a different zone. As the master pumps commits to the replicas, you will basically have inter-zone traffic. Another situation where these charges occur is if you need to take snapshots of something. So there's cloud storage called S3 in AWS, and depending what your instances are doing, you may need to take snapshots, data snapshots. And again, if servers in one availability zone go down, you may need to pump a snapshot over to instances in a different zone. Okay, but if, assuming your service is not really, that mission critical. Like you're not the ambulance dispatch system of Zurich or whatever. You may be in a position where it's okay. I deploy everything in a single availability zone, and I don't have to deal with this. What is also typically in the mix here is, so you have so-called security groups. You have a security group that you can associate with instances, and typically there's a security group for the elastic load balancer. Okay. A security group is a firewall, for instance, and so it allows you to basically determine who's allowed to access what instance from where. Okay, any questions regarding this?
The load balancing.
Yes.
Does it automatically forwards the request to the particular server based on the region of the requester?
There's some stuff regarding that. There's also like there are also issues with what's it called. If you have something like a session, if you want to like some kind of sticky session, so you can do things like that. Like if you basically, if you have a backend system and you have something like you want to book a bunch of flights, so you have a user interacting with the service, and you want all the requests of this user to be sticky, to go to a particular server, or at least to a particular zone. There are things like that. That means to achieve that in AWS.
And the load balancer is in particular zone, or is on top of the zones?
It sits. It's in a region.
It's a region. Oh.
Okay, so it straddles a number of availability zones. This is why you can have instances across AZs being attached to a single device. Okay, so
the load balancing is done by internal redirection or by DNS, or what's that?
So Elastic Load Balancer, if you get one from Amazon, it's like a black box. I think it does round robin. So you basically associate your instance with a load balancer. There's a health. There's the notion of a health check. So let's say if you have 10 instances attached to a load balancer, you can specify like a check so that the load balancer, like you give the load balancer like a URL that it pings every so often. And if that's successful, and you can also say for instance to be considered healthy, this ping has to succeed 10 times in a row. Okay. And if it fails 2 times in a row, it's considered unhealthy. Okay. In which case, the load balancer sort of exclude that instance that would not route traffic to it. So, but my understanding is it's just like it's just round robin. Okay. So here's some stuff that people are trying to do. Like one question is like how can I make my system scale up and down? So there's two ways to do this. So let's say you have a service with predictable load patterns. So you know, for example, nothing's happening during the weekend. So that means you can say you can have like an EC instance fleet of 100 instances during the workdays, and on the weekend you can shut it down to 10 instances. Reduce it in a scheduled fashion. Okay. That's one way. The other way is the much more sought after way to scale up and down with load. So as load increases, you want instances both online, and if the load decreases for a certain while, you want instances like shut down and provisioned in order to save cost. The other usage of elastic load balancers and auto scaling groups is, let's say you don't really want to your EC instance to increase or decrease. You just want to You just want it to stay healthy. Okay? So in that case, your load balancer will ping your instances as you configured. And if the load balancer says any one of these instances is unhealthy, then then the auto-scaling group will basically just make sure that it's shut down and that a replacement instance is being brought up. So you see, you have your tier, some kind of web server tier or application server tier, just to keep it constant. Okay, so what are the ingredients for this? CloudWatch, I already mentioned. So these are 3 services that AWS offers. So CloudWatch allows you to monitor and collect metrics about instances. Not only about instances, also about any other pieces of AWS infrastructure. And what you can do as well is, and which is important in this context, is you can define alarms. Okay? So you could say if the average CPU utilization grows to 70% over a period of 5 minutes, then I want an alarm to fire, to trigger. Okay? And so such an alarm triggering can, or such an alarm firing can trigger actions. So this is how it works. So you can say, okay, this is what I consider an alarm condition. It fires, and then you can associate that with an action. So that action can be something fairly simple, like somebody being sent an email, or queuing a message in a simple queuing service queue topic. It's another service that Amazon offers. Or the alarm firing can trigger an auto-scaling action. Then we have auto-scaling. Yes?
Just on the CloudWatch, do you know if there is a way to set up also monitoring of not only the physicality of the server, but also of the applications, like New Relic would do, or so actually monitoring your application server?
Yes. Yes, what you can do is, so CloudWatch allows you to issue your own metrics. So you can have like Nagios running, so your application server, application, and you have Nagios monitoring it. Okay. And now if some threshold is crossed, what Nagios can do is, or the script, okay, it can basically issue, it can create, it can feed CloudWatch data into the stream. So you can have your own metrics. You can create your own metrics, like application server X too slow, but you need to set up. You need to set up that infrastructure yourself. You need to have something that monitors the application server, and if some threshold is crossed, then you use the AWS API, the CloudWatch API, to create like a metrics data, your own metrics data, and you can associate it with tags, a lot of metadata, and that then can trigger alarms as well. It's fairly sophisticated in terms of what you can do. Okay, and as I said, auto-scaling allows you to launch and terminate instances in an automatic fashion, right? Nobody wants to be woken up in the night and says, hey, our system is burning or fuming or whatever. Can you please do something? You want everything just to hum along. You want this magical purple line. You saw the first line. You saw the first line. Okay? And last but not least, this is the foundational service, EC2, the instances themselves. Okay, I will leave this on CloudWatch, and again, this is just a glimpse of what CloudWatch can do, just to give you an idea. So, the kind of metrics that are available by default depend on what you want to monitor. Okay, let's say for EC2 instances, you have these: CPU utilization, read-write access to disk, and also network traffic in and out. Okay. For elastic load balancers, you have different predefined metrics like latency, or the number of requests, or the count of healthy versus unhealthy hosts. Okay, so there are predefined metrics for elastic block storage, if that's something you're using. And for each of these, you can define alarms. And this is a bit about what alarms look like. So you can say, given a metric, like let's say CPU utilization. You can define a threshold, which is the blue line on the graph. So in this case, the threshold here is 3. And so what CloudWatch does is it's monitoring the resource. So if it's an EC2 instance, it will monitor the CPU utilization. Okay. What's important to know is the granularity of the monitoring. So it's a minute. So you can't go below a minute. So basically every minute you can see what the CPU utilization of a given resource is. Okay. And you can then define alarms by saying, okay, I want an alarm fired if the threshold is crossed for, let's say, 2 consecutive periods of a minute. This period can be also longer. You can define what the period is and how many periods the threshold, the value must be above the threshold for the alarm to fire. And vice versa for the alarm to basically to go away. You say, okay, in order for the alarm to go away, I want to be underneath the threshold for 3 periods of an average. Okay. So in the example here, so the first thing is you have like 3 periods of a threshold. So the alarm is fired, and if there are any actions associated or tied to the alarm, they'll be blocked. And then it drops below the threshold, so it goes to OK. And then there's a spike, where the value is only above the threshold for a single period, so that the alarm will not fire. Okay? So this is the state the alarm can be in. So it can be okay, fine, no alarm. So the alarm can be in effect, or maybe if you just started an instance, there's not enough data to even determine that the alarm should fire out. Okay, so how does auto-scaling work? Well, these are the pieces you need. So you need something called a launch configuration. A launch configuration, so remember that auto-scaling needs to launch instances in automated fashion. So you won't be there when an instance needs to be launched. It can't ask you, what kind of instance will you like? Okay. Which type, how much memory, this, that. So you need to prepare something called a launch configuration. It's like a blueprint or a template. It says, okay, if I need to fire like an instance, this is the launch configuration. These are the parameters that apply. Then you need a load balancer or an above and alarms and scaling policies. So you will need to define alarms, like what constitutes an alarm for the system. And then with each alarm, you will define 2 scaling policies. One for scaling up and one for coming down again. Okay. All of this can also be turned off. So if something goes horribly wrong, if your system behaves totally out of order, or if you have like a million more customers than you typically have, there's a big red button you can hit. It's okay, stop. I don't want any other stuff. Another important property is, or go back to the slide. Interesting property is something called a cool down period. So if you look like at time 5 or time 3, when this alarm fires, okay, the associated auto-scaling action will be executed. Let's say you'll add 10 instances. Okay. What you can define as well is a cool down period, saying, okay, I don't care about any alarms firing in the next 5 minutes. So just don't do any auto-scaling in the next 5 minutes. Let the system cool down a little bit. And then, so all alarms in this cooldown period will be ignored. So I mean, they will fire, but the associated actions will not be executed. Okay, then you have scaling policies. This is basically, this defines what should be done when the alarm fires or goes away. So in the case of an EC2 instance, you can basically specify an adjustment. So typically, you want to adjust the size of your EC2 instance fleet. Okay? Adjusting means increase or decrease. And there's a number of ways to do this. So you can like change the capacity. Say, okay, add 10% of what I have right now. Okay. Or you can say, oh, this alarm is so bad. Just make sure that the size of my fleet is 1,000 exact capacity. And sorry, the 10% thing is percent changing capacity. Changing capacity means it's a number. If you want 10 more, you say plus 10. If you want to decrease your fleet by 10, say minus 10. The adjustment is basically the number that goes along with the adjustment time, and then the cooldown. Just a number of seconds to just step away and say, let these alarms fire, let the system cry. I don't want to do any auto-scaling anymore for this period of time. Okay, now it's demo time. So what I have here is, I'll show you first. Basically, I have a simple server that does some mathematics computations in order to generate CPU load. And I will fire 4 clients that hit it with requests. And this is how the client, this is the lifetimes of the clients. So client A will go on for 14 minutes, and then it's client B, client C, client D, and you see they are like overlapping a little bit. So what you want to see ideally, as the other clients come online and start hammering the server request, we want to see instances being brought up, provisioned, and as clients go away, stop hammering the server, we want the instances being provisioned. Okay, so let me close this for a minute. And let me show you the configuration scripts first. Once we're through with the configuration scripts, I will need you to take a very short break, 2-3 minutes, and basically get connected to the internet so I can run them. Okay, so the first thing I'll show you is something called Cloud Init, the Cloud Init script for the virtual machines. So the question is how? Okay, so I can boot up like an Ubuntu virtual machine in the cloud. Okay, and then I have Ubuntu server sitting there. Cool. What next? Like, how do I deploy my stuff on it? How do I make sure it runs the packages that I need to run? So how is this thing? And one common way to do this is via Cloud Init scripts. It's something that the Ubuntu server team has developed, and this is being adopted by many others as well. So let me show what the Cloud Init script looks like in this case. Okay. Okay, so what you see here is a template. Oh, nice. So is this the public component? Okay, so the demo is rescue. Okay, so if I go to this repository. Here. And applications. And today. And network code. Okay, so here's what the code I'm showing. And here's also like a